we're going to learn how to complete the square. This is a process necessary if you want to graph things like parabola, ellipse, circle, and hyperbola. All the things that we're going to be graphing in Chapter 8. So recall that the square root property says that if you have x squared is equal to some constant number, then x has to equal plus or minus the square root of that number. For example, if I had x squared is equal to, let's say, 64, and I took the square root of both sides. The square root of 64, we know, is 8. But what is the square root of x squared? When the index is even, you must guarantee that the answer is positive. Do you know what x is? If you don't know that it's positive, we must include bars so that we can guarantee that it's a positive answer. Well, recall Chapter 1, Section 6, when we did absolute value problems. If there are 2 bars, then what you're going to have as a result is 2 problems. Either that the x is equal to 8 or the x is equal to negative 8. So that's where this plus and minus come from. The bars have 2 possible answers. So consider again that x squared is equal to 25. So if I took the square root of both sides, I would have x equals 5, or I could have x equals negative 5, because negative 5 squared is 25. To complete the square, you must add enough so that the expression can be rewritten as a binomial squared. That's why we call it complete the square, and so we'll have a square. When there is an equation involved, you'll need to keep the balance. Now I mention this because right now we're not going to do equations. I'm just going to give you this expression and we're going to learn the technique used. Add the correct constant to complete the square, then factor it as a perfect square. To do this, we'll take half of the coefficient of the non-squared variable and square it. So if this is the non-squared variable, we're going to take half of 14, and then we're going to, that answer being 7, square it. So we write a 49 up here. Now I want to write that as a perfect squared binomial. Well, breaking down the first, y, breaking down the last, 7, checking your signs, both pluses, we get y plus 7 squared is the same thing as y squared plus 14y plus 49. Trying that again, when things get a little bit more complicated because they're not an even number, half of negative 7 would give you a result of negative 7 halves. And then you're going to want to square that. Squaring a negative gives you a positive, 49, and squaring the 2 gives you a 4. Now here, if I break down the x squared, so I can factor this, I have an x in the front. If I break down 49 fourths, I'll get 7 halves. I'll check the signs. This is a plus, they're the same, but this is a minus, so they're both minus. So here I have a perfect squared trinomial. Notice that this number inside here, when I'm squaring it, is half of that leading coefficient of the non-squared variable. One more shot at this, getting a little bit more complicated. How do you take half of a fraction 3/4? That's right, you get 3/8. And then you would have to square that. So 3 squared is 9, 8 squared is 64. So if I wanted to factor this expression into a perfect square, I would break down the first, w, and I'd break down the last, 9/64, I can write as 3/8. I check the signs. This is a plus as well as that one, so they're both going to be a plus. For these examples that I've done right now, the leading coefficient is 1. This process is going to get a little bit more complicated when we change that leading coefficient for the squared term to being a number. Stay tuned and go to the next example.